Hello once again. Our today's question is tan inverse of x. Okay, I'm welcoming you to be with us till the end of this video. This is an integration by part method. The method which shall be used here is integration by parts. To integrate this, I will let this stuff to be u, this one to be u. Let u be tan inverse x. Applying everywhere tan, we have tan u, which is tan of tan inverse x. This is clear that tangent and its inverse one cancel another. We have x, which is tan u. Okay, what is done here? We are going to differentiate both sides so that the derivative of this will be the same as the derivative of this. Here the derivative of x is 1, but the derivative of tangent is, what we only do is to differentiate this u. Let's write the derivative of u, then multiply the square of tangent of u du k. Sorry, here is only du. Du is this. Okay. Remember our u derivative. This is the same as writing du over dx times sec square u. This is 1. Multiplying the crossing the product. What do we have? We have sec square du, which is dx. Okay. While we let here multiplying 1 doesn't change what we've been given. dv is the same as dx. Okay, dv is the same as dx. Integrating both sides, we have v, which is x. Remember here we omit the constant of integration. And here du, look, have a look. Du here, du will be dx over sec squared u. And we know sec squared theta, which is 1 positive tan squared theta. Du will be dx over 1 plus tan squared u. And remember our u was tan inverse of x. Okay, here du is equal to dx over 1 plus tan of tan inverse, because our u is tan inverse of x power 2. This, remember, tan of tan inverse will give only this stuff. That's why du here is equal to 1 over 1 positive. Since this will be x power 2, here we'll be writing x power 2, then times dx. Okay, let's proceed. Hope everything is clear here. Let's continue in our calculations. We assumed u to be tan inverse of x, where the derivative of u with respect to x was 1 over 1 plus x squared, and we are going to apply the properties. Okay, we have tan inverse x dx. This will be, we have u times v here is x times the inverse tangent of x minus an integral of v, and our v is this. Our v is x times du, which is 1 over 1 plus x squared dx. This integral is x tan x minus, I want you to look, the derivative of this, then the derivative of the denominator is 2x, and on numerator we only have x. To make it 2, we want to multiply the denominator by 2 and the numerator by 2, 1 plus x squared dx. As you see, we have x tan x, is it tan inverse, I'm sorry, tan inverse of x, minus, I want to put these two out of this integral sign, that's why I have a half of integral of 2x over 1 plus x squared dx. The integral tan inverse x dx is then x times tan inverse of x, because the derivative of this gives this. The integral of all this stuff will be a natural log of the denominator times ln 1 plus x squared plus a constant of integration. Thank you for being with us. I want you to always remember to share, to like our videos, and subscribe to our channel. Thank you very much.